Assalamualaikum warahmatullahi wabarakatuh. My name is Raja Abdul Hadi Putra bin Raja Ismail Idham, metric number AA220740, and I am going to introduce the topic of this project-based learning. In mathematics, an ordinary differential equation, or ODE for short, is a general term for an equation made up of one or more functions of a single independent variable and their derivatives. A function with one or more derivatives is a component of a differential equation. An equation linking the independent variable, the dependent variable, and derivatives to order n-1, which is constant for all solutions of the ODE, is known as a first integral for an nth order scalar ODE. For systems of ODEs, first integral are defined analogously. The rate of change of one variable with respect to another variable is represented by a function's first order derivative. For instance, in physics, we define a body's velocity as the rate at which its location changes in relation to time. Common differential equations are used in everyday life to compute electrical current flow, describe the motion of an item like a pendulum, and clarify thermodynamic principles. Additionally, in medical terminology, they are employed to graphically monitor the progression of diseases. Differential equations are used in a variety of more typical situations such as bonds between atoms and molecules, systems of the electric circuit, population growth, to describe the motion of pendulums, exponential growth of bacteria, to find the velocity and acceleration, to determine radioactivity decay, and technology.
Assalamualaikum. My name is Nohar Izzat bin Azizi. My number metric is AA220041. Okay, for the next part is a filler table. For the question 3, a population of a small city had 300,000 people in the year 2000 and has grown at a rate proportional to its size. In year 2005, its population was 400,000. A. Find a expression for the number of the people in the city 3 years after the year 2000. B. Estimate the population of the city in year 2010. And C. Assuming the growth continue at the same rate, when will the town have 1 million people? For the question 3, the pillar table. First, the fact there is no many people population in the small city. There are too many people population in the small city. And the second, the population increased rapidly over a year. Okay, for the idea, the reason want to estimate the population of the city. The city is small to support too many people. Number 3, the population has grown at the rate proportional to its size. And the fourth, uncontrolled birth rate. Next, the learning issue. Why is the city having a rapid growth population? Second, how to estimate the population of the city in a year. Third, what should they do to solve the problem? And fourth, how to make the city to support 1 million people. And the action plan. First, list down all the problem. Second, identify the better way to control the population over a year by reference book population. For the question 10, Susan bakes a cake for her son's birthday. She removed the cake from an oven with a temperature of 56 Celsius and placed it in the room of 32 Celsius. 5 minutes later, the cake cooled down to 49 Celsius. Find the temperature of the cake after 50 minutes. To decorate the cake, it needs to cool down to 35 Celsius for the best result. How long does Susan need to wait before decorating it? Okay, for the filler table for the question 10. First, the fact. Susan want to decorate the cake, but she must wait for a cake to cool down. Second, the cake take a long time to cool down. The idea, the reason. First, want to decorate her son's birthday cake. Second, the cake took time to cool down to 35. Then she love to bake a cake. Then she want to decorate the cake as soon as possible. The learning issue, why she want to cool down the cake. Second, how to make the cake cool down faster to 35 degree. Third, what temperature should she use to remove the cake from the oven. And fourth, How long does Susan need to wait before decorating it? Okay, the action plan. First, identify the fastest way to cool down the cake temperature. Set up the right temperature for the cake to cool down. And third, by reference book Newton Law. That's all.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Sufi Shikri bin Muhammad Rashad. Mathematics AA 221993. We present about the solution. The question about population. Number 3. The population of a small city had 300,000 people in the year 2000 and has grown at a rate proportional to its size. In the year 2005, the population was 400,000. A. Find an expression for the number of people in the city T years after the year 2000. The first question is you want to search for T. So you see the P is 300,000 and the T is 0. And for P 400,000 and the T is 5. So the formula of population is P equal to AE power of KT. So you just put the P inside the P, about 300,000 equal to A E power of K, and T you just insert the 0, the amount it, and you will get A equal to 300,000, and you just put it in the formula and you will get P equal to 300,000 E power of KT. So just put the P for 400,000 to the formula. So you get 400,000 equal to 300,000 E power of K, and T you put 5, and in the last you get K equal to ln 4 over 3 over 5, and you get 0.0575, and you put back in the formula, you get P equal to 300,000 E ln 4 over 3 over 5 darabkan T. Okay, move on to the B question. Estimate the population of the city in the year 2010. At the question you will know T equal to 10. So in the question we want to search P. What is P? So you want use the formula back that you have calculate at A question. So P equal to 300,000 E exponent. E is exponent power of in ln 4 over 3 over 5, and T you insert 10, and you get 533,333.33. So you have to bunda it. P sama dengan 533,334 people. And and the question C, assuming the growth continues at the same rate, when will the town have 1 million? So at the question you get P equal to 1 million. So just you just want to search the T is year, and just insert the formula P equal to 1,000 equal to 300,000 exponent of in ln 4 over 3 over 5 T, and you just pindah-pindah, and last you get T equal to 20.93, and just bunda it, and you get 21 year. And the initial year is 2000, and you have to plus it with the answer you get. So 2000 plus 21, so it equal to 2021. So when year 2021, the town will have 1 million people.
My name is Muhammad Zain Maris, metric AA 221658. To find the temperature of the cake after 15 minutes, we can use the concept of thermal equilibrium and assume that the cake cool down exponentially with time, using the equation for exponential cooling. When T is the temperature of the cake at the time T initial is the initial temperature, T final is the final temperature, and K is a constant. Given that the initial temperature of the cake T initial is 59 degrees Celsius, the final temperature T final is 35 degrees Celsius, and the interval is 15 minutes, we can plug the value into the equation to find K. See, we simplify the equation we have, and then divide both sides by 15. Taking the natural logarithm ln of the both sides, and then solving for K. Since K is 0, is indicate that there is no exponential cooling occurring. Therefore, the temperature of the cake remains at 59 degrees Celsius after 50 minutes. To reach the desired temperature of 35 degrees Celsius for the characterization, need to wait longer than 50 minutes without further information or a specified cooling rate. It is not possible to determine of exact time need to reach 35 degrees Celsius. The cooling rate may depend on various factors such as the size and thickness of the cake, the insulation properties of the time of the room, and the airflow. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Najwan bin Muhammad Salam. My metric number is AA221635. Alright, for the discussion and conclusion for A, population, we choose question 3. So from this, with the application of first order ordinary differential equation can be used to calculate growth population in certain places. It is also can help calculate to estimate the population upon upcoming year or past years. It is also can make a suitable expression for calculating the population for a certain equation. Alright, for the B part, Newton's law, we choose question 10. So for that, with the application of first order ordinary differential equation, we can find the specific temperature on specific time by using the application of first order ordinary differential equation. We can also predict how long time need to do a task on a specific situation and for the task to be done. Same goes as useful as a Newton's law. Alright, for the conclusion for this studying, by studying the application of first order ODEs, we have gained a solid foundation in understanding the behavior of a dynamic system and the mathematical tools required to model and analyze them. This knowledge can be applied across various disciplines, ranging from physics and engineering to economics and biology. This can enable to solve real-world problems and make prediction about system behavior. That's all from us. Thank you.